Hello students, myself Dr. Anupreeta Mishra and you are watching Anupreeta Mishra's Electrical Engineering channel. Here I am today discussing with you about the alternative derivation for the synchronous speed, and that derivation is going to be helped out with the relation of mechanical angle and electrical angle. This is in a layman language I can explain you the difference between the mechanical angle and electrical angle as mechanical angle is nothing but what the angle you can observe spatially or on structure, on mechanical structure, whatever angle is being observed, that is known as the mechanical angle. And electrical angle is nothing but the phase angle of electrical quantities, either EMF or current, etc. First, I would be deriving or discussing the mechanical angle and electrical angles connection, and later that relation is going to be the base for alternative derivation of the synchronous speed actually. So here I would be discussing what I said first. I am having a structure of synchronous machine in which stator winding is being given over the stator and rotor is having rotatory poles. Why I have taken up the structure related to synchronous machine? Because recently I am going with my lecture series of synchronous machines. That's why. Prior to that, twicely I have derived the same relation, this one, for induction motor. Then I did for synchronous machine, and later now I came up with the new alternative derivation of the same quantity, physical quantity, speed, synchronous speed, but that is going to be with the help of relation between mechanical angle and electrical angle. So as I said, stator is having armature winding and rotor is having rotatory poles. So this I am showing two pole structure of the rotor, that is one north pole, one south pole, or a pair of pole, and here I am showing two pair of poles, means two north pole and two south poles. Here I am assuming that rotor is rotating in the clockwise direction with capital N speed. Instead of this, I can consider conductor A or armature windings conductor A, which is being shown here. Only a single conductor I am showing. So conductor A is rotating in anti-clockwise direction with respect to that of the stationary north pole. This I can assume. And why I am assuming this? Reason being, I want to know the magnitude of EMF as well as the direction of EMF induced in this conductor due to the rotation or cutting of the flux through Fleming's right hand rule, and that rule says that the conductor itself should be in a moving condition. So here relatively I am showing the motion of the conductor in anti-clockwise direction so that I can apply Fleming's right hand rule to find out the EMF's direction, and later I can utilize to find out the magnitude of EMF also. So here, as the conductor is moving in anti-clockwise direction and number of poles whatever are being utilized here are stationary, rotor is having zero rotatory speed. So with respect to that, this conductor I am taking up the direction of the flux emerging out of the north pole like this. So this is the field's direction. This is the motion of the conductor, so it is rotating in this direction. So I am keeping my thumb in this direction. So my middle finger is going inside the board. So this would be saying you about the direction of EMF. So this terminal is having positive polarity and this terminal will be having negative polarity. So the outer terminal which is being observed to you, the cross section of it, it would be having negative polarity, and inner terminal would be having the positive polarity. So that means when conductor is against north pole, that time that conductor is having the maximum EMF induced in it, and I am showing that position as and identifying that position of relative position of conductor with that of the north pole as 1. So I am showing that one position over here. So EMF is having positive polarity and maximum EMF is there. Now conductor is coming over the second position. Here it is a neutral position, so neither positive EMF nor negative EMF, nothing will be induced here, zero EMF is there. So this second position is being identified over the waveform here. This waveform is nothing but in between the magnitude of EMF and the angle by which the rotation is occurring, mechanical angle, electrical angle, all the angles I'll be showing over here. Here second position gives me the zero induced EMF, so it is zero. Later, when the conductor arrives here at the third position against south pole, so it would be having the maximum negative EMF induced in it. So this would be the third position and EMF induced in it is negative. Then later it comes to the fourth position. So here again at the neutral position, it would be having zero EMF. And then again it is going towards the first position. So conductor achieved one position, second position, third position, fourth position, and again first position here. So it would be having this complete cycle when the conductor itself moves by 360 degree mechanically. So it would be completing or creating, I should say, inducing one complete cycle of EMF in it, in that conductor itself. So instead of this, I am showing the cycle over here. So from here to here, mechanical displacement of the conductor is by 360 degree, and similarly induction of the EMF is also having the one cycle, that means it is 360 degree. And again I am saying that one cycle of electrical quantity itself reflects 2 pi angle of 360 degree. So 360 degree here. So in one rotation of conductor, spatial rotation of conductor, turns it by 360 degree or traces the 360 degree, in the same manner in two pole machine, conductor would be having the induction of one cycle or 2 pi angle, tracing electrically also, from here 1 to 2, 3 to 4, and then again to 1, that way. What does this mean? Here it means electrical angle and mechanical angle are exactly same. So I wrote here theta m is equal to theta e, because both are tracing the same angle, mechanical 360 degree and electrically 360 degree. What would be there if the number of poles are 4? So here I am taking 8 positions of the conductor. Similarly, conductor is rotating here in the direction of anti-clockwise direction and poles are stationary. So 1, 2, 3, 4, 5, 6, 7 and 8 position, and again it will come to the first position after complete revolution, one revolution. So when the conductor is against north pole at one position, it would be having maximum EMF this way. When it comes to 2 in between north and south pole, so it would be having, this is your south pole, this is north pole. I wrote it outside, but I am writing it now inside. So north pole, when it comes to the south pole, against the south pole, that conductor, it would be having negative EMF. This third position reflects that one. When it comes to conductor comes to fourth position, so it would be having zero EMF, because here it is neither in the impact of south pole nor it is in the impact of north pole. So zero EMF. When it comes against the north pole, so mechanically it has been rotated by 180 degree, but what electrically it would be creating, that I can show here itself. So when it comes at fifth position, a conductor comes at fifth position against north pole, again it would be having the positive polarity of the EMF. So this fifth position would have this maximum EMF in positive direction. When conductor comes at sixth position, again it would be having zero EMF. When it comes to against the south pole, it would be having negative maximum EMF. When it comes to eighth position, it would be having zero. And when it reaches back to first position, again it would be having positive EMF. So when 360 degree completion of mechanical angle displacement is there, angular displacement is there, electrically it is producing 2 cycles. Now instead of this, I am just shifting my fingers over here. So from here to here, 360 degree mechanical angle displacement is there, but in between that, electrically it has produced 2 EMF cycle, because 2 pair of poles are there. So one mechanical rotation, 2 pair of poles are being pressing out by the conductor. That's why it would be having 2 cycles of EMF 0 to 360 degree. Mechanically, it would be having twice into 360 degree, means 720 degree elapsation would be there electrically, I should say. So here at a machine of 4 pole, I can say that 360 degree of mechanical is equivalent to 720 degree of the electrical angle displacement. So theta m is 90 degree here in this case. So when 90 degree mechanical angle displacement is there, so electrically it would be having the displacement of 180 degree electrical. Similar manner in mechanically 360 degree displacement is there, angular displacement of the conductor, electrically it is producing twice the 360 degree, that means 720 degree. If we have 6 poles machine, what would be there? If 2 poles machine, so 2 comes over here in multiplication with 360 degree. If I have 6 poles machine, so it means that it would be completing conductor, if tracing out 6 poles through its rotation in one revolution, it would be tracing 6 poles, 3 pair of poles. So certainly it would be having the induction of 3 cycles of EMF. So when mechanically 360 degree tracing or revolution of the conductor occurs mechanically, so it would be having 3 cycles of electrical EMF induction in that conductor. So here it would be having 3 into 360 degree between this particular points. Here mechanically it would be having 360 degree mechanical angle. So here I have 3 into 360 mechanical angle electrical displacement in these 2 points. So if one pair of pole is there, so one cycle of EMF, two pair of poles are there, so two cycles of EMF, three pair of poles are there, so three cycles of EMF, four pair of poles means eight poles are there, so four electrical cycles would be occurring. So I can say that if P number of poles are there, so P by 2 times of 360 degree, this much electrical angle would be occurring. Two pair of poles, so 2 into 360 degree, three pair of poles, 3 into 60 degree, four pair of poles, 4 into 360 degree, P by 2 pair of poles into 360 degree, this much electrical angle would be there, this much electrical displacement would be occurring in the points, corresponding points. So instead of this 360 degree, I can substitute theta m. So it is giving me theta is equal to P by 2 into theta m, because theta m is 360 degree. So P by 2, 360 degree is replaced by theta m. So I would be having a simplest relation between electrical angle and mechanical angle by this relation. Theta is equal to P by 2 into theta m. Again, I am telling you, here one pole pair is there, so 1 into 360 degree. Two pole pairs are there, 2 into 360 degree. Three pole pairs are there, so 3 into 360 degree. Four pole pairs are there, so 4 into 360 degree means 4 cycles will be there for one revolution, mechanical revolution of the conductor. So if P number of poles are there, so how many cycles would be generating in the conductor for that complete one cycle of mechanical cycle of revolution? So it would be having P by 2 number of P by 2 360 degree. So P by 2 times of 360 degree would be electrical angle. This is your electrical angle. This is your electrical angle in between these 2 points. So I would be having P by 2 into 360 degree. So P by 2 into 360 degree, this much electrical angle would be existing there. So I am replacing 360 degree by mechanical theta m angle. So P by 2 into theta m is equal to theta e. This is the simplest relation between theta m and theta e. That's there. Now I am using this relation to derive the relation of speed, synchronous speed with that of the frequency and number of poles. So again writing theta is equal to P by 2 into theta m. Now taking derivative of both the sides. So d theta e by dt is equal to P by 2 d theta m by dt. This is nothing but the omega e rotational speed, and this is also rotational speed omega m. But this is related to electrical angle and this is related to mechanical angle. So this actually reflects the frequency. So angular frequency is nothing but omega e. Normal electrical frequency is f. Angular frequency is omega e, and it is written over here in words also. P by 2 is there, omega m is angular speed. This is actual mechanical speed of the object or rotor, I should say, or stator, whatever I am considering, stator conductor. So omega e can be written as 2 pi f and omega m can be written as 2 pi n. Small n is nothing but revolution per second, RPS. So P by 2 into 2 pi n. 2 pi gets cancelled out, f is equal to Pn upon 2 that way, or small n is equal to 2f by p that way, but it is in RPS. If I want to convert it into RPM, so I can utilize this relation, small n is equal to capital N upon 60, where capital N is RPM. So that way what I am doing, I am multiplying this expression on both the sides by 60. So 60n, 60 into 2f by p. So that gives me capital N is equal to 120 f by p, and this is the alternative derivation of synchronous speed, what I said earlier. Hoping that you people are liking my way of teaching and understanding each and every minute concept of electrical engineering. So please do like my channel, my videos. You can comment me your problems also. I will sort them out by my best actually. And please subscribe to my channel. Even suggest your friends to subscribe my channel. Thank you.